Well, what is a combination system?
Well, a combination system is what you would use when you're on the road. You're going to use the battery to run your refrigerator or some essential equipment that's in the tiny home to make sure the food is refrigerated or the fan can run. But the AC is what you would connect when you're at an RV site, and that's what you would plug into the disconnect that's provided at the site so you can have 120 to 240 volt system. That's considered
Okay.
higher voltage.
Well, it says that a voltage converter here um, is all converters and transformers shall be listed. Obviously, everything that we do put into a tiny house needs to be listed. That means like UL listed or
Yes.
something like that. But it says the 120 volt AC side of a voltage converter shall be wired in full conformity with the requirements of part 1, 2, and 4 of this article for 120 volt electrical systems.
Yes.
So what does that mean when it says that?
In the article, there is sub-articles. Like you've got Article 551, and I'm just giving you a basic on how it's laid out. And then you got 551.1, and then it goes up in numbers that way.
Okay.
Also in that, they divide the subject matters into parts. And the parts is concerned with a particular type installation. Like the first part of 551, it's general. The second part is about combination electrical systems. And then when you get into the third part, it's about other power sources. So what they're talking about is they're trying to break it down into a specific installation that you're doing, and you adhere by all the National Electrical Code standards.
Oh,
So it's
okay.
like reading a encyclopedia, but if you break it down in the article that you're concerned with and what you're installing, it makes complete sense.
So in other words, if we're at Article 551, we could be in Part 1, 2, or 3, or 4, or
That
those are
is
different
correct. It's
parts.
it's
Okay.
according to what you're installing and where you're looking for the installation standards.
Okay. So now we're talking about combination electrical systems. So we're
Yes.
talking about AC and DC, which would be like a combination system.
Yeah, and every tiny home will have that because they use DC on the road and AC when they're parked somewhere.
Okay. Now, we're going to talk a little bit more about bonding, but it says here that the bonding, the voltage converter enclosures, that it needs to be non-current carrying metal enclosure of the voltage converter shall be connected to the frame of the vehicle with a minimum 8 AWG copper conductor. Voltage converter shall be provided with a separate chassis bonding conductor that shall not be used as a current carrying conductor. Can you explain that a little bit?
Well, AWG, what they're talking about is American wire gauge. That's in Chapter 3 of the National Electrical Code, and it defines the sizes and the voltage levels. When you're looking at a conductor, American wire gauge, there's a couple of things to consider. The insulation has to do with the amount of voltage that can be applied to the conductor, and the size of the conductor has to do with the ampacity rating of what size current could go through the conductor before it starts to heat up and break down. So with that being said, they're talking about bonding. They require a certain minimum size to ensure that if you had a fault, something shorted out, that it would go directly to the grounding system of what you're connected to, extinguish that so you do not get shocked. So what's going to happen is the breaker is going to sense a large amount of current in a short period of time. The conductor is carrying that amount of current, and it trips the breaker so it can safely ensure that the conductors do not burn up. In the
Okay.
meantime, you're not getting hurt. It's the system that's taking the fault. So they make sure that the wire size is large enough so it can carry that for a short period of time before the breaker trips. And it all has to do with time, and the factory set breakers at certain times. As current rises, time shortens. So the higher the current is, the quicker the breaker trips.
Got it. Okay, so we're going. So in this case, if you have a converter, a metal converter with a metal enclosure, then that
Yes.
needs to be bonded to the what does it say here? The chassis.
The chassis, because that is a steel chassis that the tiny home is sitting on, and it's a common place for everything to go to.
Okay.
Everything's
All right.
anchored to that, and that's what keeps the tiny home secure, so it can be transported down the road. And they make sure they bond it to metal, and that's the best place to do that, because that's the
Sure.
main.
That makes sense. Well, they also talk about, there could be outlets for 12 volts and there could be outlets for 120 volt. And they say in here that those outlets, it says the connector shall have a configuration that will not accept the AC power. So I think what they're saying is the receptacles have to be different for the 12 volt and for the 120 volt
Yes.
receptacle. Is that what that is?
Yes, in Chapter 3 of the National Electrical Code, there is NEMA configurations. NEMA is the National Electrical Manufacturers Association, and they design receptacles for voltage levels that they're rated at and for current levels that the ampacity can take on the receptacle before it breaks down. They configure these so you do not mix voltage levels, and you put the right receptacle male plug into the receptacle outlet. That's already done for you. You just need to make sure that you confide by what's in the code. And if it tells you a NEMA configuration like NEMA 12R, well, then you need to make sure that that 12 is the configuration of the receptacle, and the R means receptacle.
Okay.
P
All
means
right.
plug. That's going to be your male plug. So they want to make
Okay.
sure that you put apples with apples and not apples with oranges. That's what it boils down to.
I got it. So in other words, it's possible to go out and buy if you're doing it yourself and you don't know what you're doing, or maybe you think you know what you're doing, and you go out and you buy a 120 volt receptacle and wire it up to a 12 volt system, that isn't going to work, and that's against the code.
Yeah, well, it's against the code, and it violates NEMA and it violates UL. This is where UL, Underwriters Laboratories, comes into effect, where they make sure that things are safely manufactured, and NEMA has to abide by them too. So they require that NEMA puts on that number on that receptacle device. So the easy part for you is to make sure whatever the code requires in a NEMA, it will go by voltage, it will go by amperage, and it will go by the style. And that will be marked on the box or on the receptacle device itself. Same way for male plugs.
Okay. Well, this is a good place to talk about the whole National Electric Code. So we're in one little section here, Article 551, but you keep referring back to different places
Yes.
in the National Electric Code. So when you're doing a tiny house, it means this is what you're going to focus on, but you still have to know things in the rest of the code. Is that what you're saying?
That is correct. Chapters 1 through 4 is the nuts and bolts of the National Electrical Code, and the rest of them have to do with specific installations. Chapter 4 is about motor control. And then when you get into Chapter 5, it has a lot of these different articles. One of them happens to be healthcare facilities for hospitals. And so that's Article 517. So with that being said, you need to make sure that you do everything according to Chapters 1 through 4 for basic installation. And then you go to the specific article for whatever you're working on. In this case, we're talking about tiny homes. So that would
For
be Article
RVs.
551.
Recreational vehicles, yeah.